Hello friend, how are you? I'm fine. Thank you. I hope you are all will be fine. So let's start today topic. Today our topic is crystal field theory. What is crystal field theory? First I'm discussing, I'm telling you that why crystal field theory was being come it has many reasons because there was the theories like Warner theory, valence bond theory, molecular orbital theory that has some assumption that have that was that had some postulate that had some misunderstanding. So crystal field theory came and explained them these are postulate. So first of all we discuss what is crystal field theory. Before crystal field theory, all the concepts before crystal field theory like Warner theory, VBT, MOT, these all are about either it was electron transferring from a ligand to metal, or from one part of complex to another part of complex, like our hybridization, orbital become hybridized. But the ligand field theory, it is purely in this theory the ligand or the central metal ion, central metal atom, these all will be purely electrostatic, means it cannot be formed covalent bond, it cannot be explained the concepts of covalent bond, it will purely ionic concepts. So you will be clear if when we uh, explain important features. So first of all I am telling you that important important features of CFT. Important features of CFT. What is the important feature of CFT? The important feature of CFT is, first of all first of all CFT, this theory was this theory, the first assumption of crystal field theory as the central metal cation. First of all we know that the complex, that the complex has two parts. One part is a CMT, central metal, CMA, central metal atom, and the other part of this complex is called ligands. So in this concept, in this theory, these the central metal cation, central metal atom or ligands, both will be purely electrostatic, both will be considered purely ionic, both will be considered purely ions. So in this concept, in this crystal field theory, the central metal cation is surrounded by ligand. First of all, central metal cation surrounded by central metal cation surrounded by ligands. It will be surrounded by ligands. The central metal cation that will be surrounded by different ligands, so which contain one or more lone pairs of electrons. These ligand will be act as a base, like in organic chemistry, acid and base, or nucleophile, electrophile. So it will be act as a nucleophile or base, means it can donate lone pair. So the ligand will have, the central metal cation will be surrounded by ligands, and the ligand will the ligands should have the ligands should have one or more electron pairs contain so the ligand will have the ligand should have one or more than one lone pair of electron, so that so that they can act as a negative charge. It cannot be shared in this concept. The ligand cannot share the electron to certain electron, but it should have, according to this theory, it should have, the ligand should have electron pairs, but that electron pair cannot be shared to the central metal cation. This was the first feature of theory. So now the second part, sorry sorry the second the second postulate of this theory is the ionic ligand are regarded as negative charge. The ionic ligands I already told you the ionic that this theory in this concept, all the part of complex will be considered purely ionic. The ionic ligands, the ionic ligands like that is like fluorine, chlorine, bromine, and so on. You can say that are in H3, H2O, and so on. You can also write it. So, according to this concept, all the ionic ligands are regarded as are are regarded as are regarded as point charges. All the ionic ligands are regarded as point charges. What is meant by point charges? Point charges means point charges like that, in physics it will be called point charges. There is no charge that can be purely isolated. The single charge can be purely isolated. So let's suppose that is the one charge, and this is the another charge. We can compare point charges between two charges. We can get the concept of charges, point charges, when we assume that these two charges are point charges. The why What is the condition for these charges, that it will be called point charges? If the size of these point charges if the size of these point charges are less than the internuclear distance, the internuclear distance if the internuclear distance is greater than, let's suppose that internuclear distance is can be denoted by I. Let's assume that internuclear distance denoted by I. So I will be greater than the radius of, or the size of each charge. Each charge should have small size. The internuclear distance between these two charges will be greater than the size of the charge. So if this condition will fall, if this condition are followed, after that we can say that these charges are called point charges. In this case, according to crystal field theory are regarded as the point charges. All the ligands will be regarded as point charge. All the ligand can take as a point charges. If the ligands were sorry, if the ligand was ionic, like fluorine, chlorine, bromine, the ionic ligand means that these have negative charges. If these ligand have negative charges, if these ligand have negative charges, they called ionic charges. But if there is neutral charges, in case of neutral charges, what will be happened in case of neutral charges? What is neutral charge? Sorry, neutral charge, not neutral ligand. In case of neutral ligands, in case of neutral ligand like H2O, NH3, in this case H2O has two, oxygen has two lone pair, nitrogen has one lone pair. In this case, etc. In these cases, these ligand will be considered as the point dipole. These will be considered as point dipole. First of all, I told you that the ionic ligands like fluorine, chlorine, bromine, etc. are regarded as point charge. These will be considered as a point charges. But if there is a molecules, when they are neutral, when neutral ligands like H2O, Na3, etc., these will be regarded as a point dipole. What is meant by point dipole? Point dipole mean point dipole mean like H2O. So oxygen has more electronegative charge, most electronegative charge, but hydrogen has electropositive, not electronegative. So the dipole moment will be show like that toward oxygen, from hydrogen toward oxygen. So oxygen will show dipole moment. So if these when I was told you that for how is no, when I told you point charge concept, like this concept, so similarly I2 will be act as a point, but it is a molecule, so here dipole are formed, dipole moment will be established. So that's why this is called point dipole. This is point dipole. It means that the ionic charges are regarded as point charge, but neutral ligand but neutral ligand will act as a point dipole. It will be act as a point dipole. So is it clear? So the third assumption of this concept is the CFT doesn't provide for electrons to enter the metal objects. CFT, what is mean by this concept? CFT doesn't allow you. CFT doesn't allowed you, or you can say that it doesn't provide for electrons to enter the metal object. CFT doesn't allow you or provide for CFT doesn't provide for electrons to enter the object. I already told you that you cannot that you cannot make any bond like covalent bond, metallic bond. Here it is in crystal field theory, all the charges that may be positive charge means central metal atom or cations, or that is, these are ligand, all will be act as purely ionic. So they cannot share the electron. They cannot here no transfer of electron will occur, but it will be purely electrostatic. Here in crystal field theory, here all concepts are electrostatic. So if safety doesn't provide you for electron to enter the metal object, because metal object because as well as metal object as well as ligands as well as ligands both will be act as a electrostatic charges. Electrostatic, here electrostatic phenomena will be occur. So like this is central metal atom. Let's suppose that as is m power plus n means a number of oxidation number. So that is central metal atom. This is ligand. So if ligand has ionic ligand, anionic ligand, so this electron cannot be shared to this metal in this concept, but it will be purely electrostatic means that is m plus n, and that is l negative. That will be purely electrostatic means that will be act as a negative charge, that will be act as a positive charge, like in magnet, and there is north pole and south pole. Similarly it will be act as a electrostatic. It will be purely electrostatic. It will be act as a negative and positive charge, and the attraction or repulsion will be uh, occurred here. So this is the concepts of this is the part of crystal field theory. And fourth concept, and 4 point, what is the next point of crystal field theory? And this point CFT doesn't and this point no overlapping of orbital, no overlapping of orbitals will formed, will occur. So here is no overlapping of orbital will occur. And the next step I already explain you that why overlapping of orbital cannot produce hair. I already told you. So here now I'm directly going to next point of crystal field theory. Next important feature. What is the next important feature? The next point is the bonding between between or you can say that the interaction between the interaction the interaction between a CMA central metal atom and ligands. The interaction between central metal atom and ligands are not covalently are not covalently, but it will be purely electrostatic. It will be purely electrostatic. Electrostatic means the like a Coulomb interaction. Coulombic interaction. What is meant by Coulombic interaction? Coulomb law said that when there is two charges and when there is two bodies, one has positive charge and another have negative charge. When there is two charges, they will be attract or repel according to Coulombic charge. According to Coulombic interaction between two charges, between two charges, between two charges, interaction will be interaction will be present interaction will be present, but if the charges is same, if the charges is same according to Coulomb law, if the charges is same, repulsion will be occur, repulsion will be occur sorry repulsion will be occur, but if the charges if the charges is different, but if the charges is different, attraction will be happened, attraction will be occur. So this is Coulomb law. Similarly, like this concept, according to this concept, if this is central metal cation which has a positive charge, and this is the ligand, and ligand have, we know that ligand have a negative charge. So here as no transfer of electron, no covalent bond or metallic bond or other coordinate bond will be found, but here it will be purely electrostatic interaction. It will be purely attract, only electrostatic interaction, only electrostatic attraction will be present, because according to Coulomb law, if the charges is different, attraction will be occur. Here is the charge, one is positive and the other is negative, charge is different, so here will be attraction present. So this attraction, the crystal field theory is based on this attraction, this interaction. So this is the important feature. These are all about of crystal field theory. I hope all the points will be clear here. Like this is central metal atom, this is central metal atom, M plus N is the oxidation state of this metal. I'm giving an example of like this. Here let's suppose that is nickel having plus 2 charge, having plus 2 charge. If there is a 4 coordination number, 4, if this nickel has 4 coordination number, means if we interact 4 NH3 each nitrogen, in each case each ammonia have one lone pair. According to the second point, according to the yeah, according to second points of crystal field theory, neutral ligands, A2, like A2, and A2 is neutral ligand that have no not negative charge neither positive charge, so it will act as a point dipole. So it is point dipole, so it will be act as a negative sides. It has negative charge, means slightly negative, the nitrogen has slightly negative charge, because it is electronegative element as compared to the hydrogen. Hydrogen is electropositive, so this negative will be toward the nickel center metal, and here will be only interaction present, electrostatic negative positive coulombic interaction will be present, and this will be formed one complex. So in next topic and next video we will discuss that how interaction is present, how the electron face the how the orbital of nickel how the orbital of nickel can face the coming electron coming the ligand that approach to the central metal atom. I hope you will be clear. So in next chapter in next class we will discuss, we will explain, we will give an example about crystal field theory. I hope you will be clear, all the point will be clear. So take any screenshot or whatever you want. If you can, if you want that you should need to write. So these all are about crystal field theory. I hope it is clear. Thank you very much. Please support me at at make me it make me happy when I see that my students are supporting me. So thank you very much. I will improve my class inshallah.